Hello students, welcome back to our channel Diksha Karnataka. So as you all know, your COMEDK exam is approaching and we have started a series where we are discussing the top 30 questions from all the high weightage chapters. Okay, so in this video, we'll be discussing the top 30 questions from one of the most high weightage topic, that is chemical kinetics. So you can easily expect 3 to 5 questions from this chapter. And most of these questions are from your previous year papers. So if you are able to solve these questions, you can have a assurance that this chapter is done for the exam. Okay, so let us start. So what you have to do now is just try solving. So just see the questions and try solving it by your own, and then you have to see the solutions. If any question you are stuck in, so just mark those questions for the revision. Okay, so let us start with the first question. So the first question is, the temperature dependence of the rate constant K is expressed as K is equal to A into e to the power of minus EA by RT. When a plot between log K and 1 by T is plotted, we get the graph as shown. What is the value of slope in the graph? Okay, so this is very important question from which topic? That is your Arrhenius equation. Okay, so if you see here, we have this equation K is equal to A into e to the power of minus EA by RT, right? So if I take log on both sides, we'll get log K is equal to log A minus EA by 2.303 R1 by T, right? Now if you see here, the slope, this is an equation where 1 by T is X, this is your Y and this is your M. So what is the slope value? Minus EA by 2.303 R. So the correct answer for this question will be yes, EA by 2.303 R. So what is the value of the slope? Okay, so value means you have to just tell the magnitude. So EA by 2.303 R. So the correct answer for this question will be option number B. Okay, so next question. Consider the following reaction P2Q. The concentration of both the reactants and the products vary exponentially with time. Which of the following figures correctly describe the change in concentration of reactants and products with time? So this is very basic question. You know, as the reaction proceeds, the reactant concentration decreases and product concentration increases, right? So P is the reactant here. So concentration of P will decrease and concentration of Q will increase. So let us see all the graphs one by one. Here P concentration is decreasing, Q concentration is increasing. So this can be an answer. Now coming to next one, option number B. Here what is happening? P concentration is decreasing, Q concentration is increasing. Yeah, this is also correct. Now if you see here, the graph for Q is not exponential, right? But in the question it was given it is varying exponentially with time. Okay, now if you see here, Q concentration is decreasing. That cannot be there because Q concentration has to increase. Now coming to these two options, right? So now as the graph is growing exponentially, if you have seen, the graph for this one will be in this form. Okay, exponential graph. So for reactant it is in this form, for product it is in this form. Okay, it is not in this form. The A option is in this form. Okay, so that is incorrect. So the correct answer for this question is option number B. Okay. Next question. For a reaction 2NO plus H2 gives N2 plus 2H2O, the possible mechanism is given. What is the rate law and order of the reaction? So if you know, the rate law is always dependent on the slowest step of the reaction, right? So in these three, you can see this is the slowest step. So I can write rate is equal to K into N2O2 into H2, right? And the order of the reaction here will be 2 because this is 1 and this is 1. So we can see order 2 here, order 2 here. So this will be the correct answer. That is your option number B. Very simple question. Next, the energies of activation of forward and reverse reactions of A2 plus B2 gives 2AB are 180 kilojoule and 200 kilojoule per mole respectively. Okay, so now let us draw this diagram first. Very important question, this one. So this question is important here. First is your A2 B2. A2 plus B2 is there and we have 2AB. Okay, so this is your reactants and I will have here 2AB. Okay, the product side. Now the activation energy of the forward reaction is 180 kilojoule. So this is your activation energy value. Okay, this is how much given? 180 kilojoule. And next, and 200 kilojoule for the reverse reaction. So for reverse reaction, the activation energy will be 200 kilojoule, right? Now the question is asked, if the presence of catalyst, the activation energy of both the reactions reduces by 100 kilojoule, right? So the activation energy is decreased. So we will draw another graph here, okay, the same one, but the activation energy will decrease here. So now suppose it was earlier 180, now it is decreased to 100 times, means now it is 80. So we will draw a reaction like this. So I'll use a different pen here. So this activation energy, this value, okay, is 80, and the another one which was 200, now this one will become 100, right? Clear? Now if you see, the question is asked, what is the enthalpy change of the reaction? So the enthalpy change of the reaction will be minus 20, okay? 80 by 80 minus 100, that is your minus 20. So the correct answer for this question will be option number A, okay? So that is correct. Now let us go to the next question. The plots are shown below between concentration and time t. Which of the given orders are shown by the graph respectively? So if you see here, the graph is versus A minus X and T, okay? So A minus X is nothing but the final concentration. So in zeroth order reaction, we have A is naught minus A is equal to KT. Now if I want to draw a graph for A, I'll take this side, then I'll get A naught minus K into T, right? So this, the negative slope value is minus K. So this is for which order? Zeroth order reaction, right? So these two options we can eliminate. Now if you see 1 by A, so for this second order reaction, if you see, the value is 1 by A minus 1 by A naught is equal to KT. So if I want to calculate here 1 by A, that value will be equal to KT plus 1 by A naught. So here it is a positive slope, okay, with the y-intercept. So this is your second order reaction. So the correct answer for this question is option number C, okay. So let us see the next question. In a reaction 2x to y, the concentration of X decreases from 0.5 to 0.38 in 10 minutes. What is the rate of the reaction? So very easy question, this one. So we know rate is equal to change in concentration by change in time, okay. So now what is the concentration change that has taken place? 0.50 minus 0.38, and you can see the units is in seconds. So 10 minutes we will convert it into seconds. So now we will get 0.12 divided by 600, or we can write it as 12 by 600 into 10 to the power of 2. So I'll get 1 by 5, that is 0.2 into 10 to the power of minus 3, or I can write it as 2 into 10 to the power of minus 4. So the correct answer for this question will be option number A, okay. So easy one. Next, for the reaction this one, then the correct relation between K1, K2 and K3, okay, very important question this one. First of all, let us write the differential rate equation. So 1 by 2 of dNH3 by dt, okay, will be equal to dN2 by dt will be equal to 1 by 3 of, so I'll write in this one second, I'll write it, the full equation we can write on the other side of this one. I'll get minus 1 by 2 dNH3 by dt, okay, is equal to dN2 by dt is equal to 1 by 3 dH2 by dt, right? Now you see what is the value of dNH3 by dt? Minus dNH3 by dt is K1NH3, right? So I can write here 1 by 2, and minus dNH3 by dt is K1 to the K1 into NH3, okay, and then dN2 by dt is K2 into NH3, so just substitute this one, and then dH2 by dt is K3 NH3, so 1 by 3 K3 NH3, okay. So now you can cancel all NH3s from the equation. So I'll get 1 by 2 of K1 is equal to K2 is equal to 1 by 3 of K3. Okay. So now you can take the LCM of 2 and 3 and just, that is 6. So multiply the whole equation with this one. So I will get 3K1 is equal to 6K2. So I am multiplying the whole equation with 6. Okay, just to see, the options are not in the fraction form. So to get the fraction form, we'll get this one 3K1, 6K2, and then we will get 2K3. Now you see none of the option is matching this one. So but you can see if we divide this equation, the whole equation with 2. So I'll get 1.5K1 is equal to 3K2 is equal to K3, right? So that is this option. So the correct answer for this question is option number C. Okay. So little tricky question, but a good question from kinetics. Okay, next, during the kinetic study of the reaction 2A plus B gives C plus D, the following results were obtained. Based on the above data, which one is the following is correct? So you have to find the rate law. So you need not solve it, just you have to understand here. So we want to find, so let us first find the order with respect to B. So when I want to find the order with respect to B, the concentration of A should be constant. So in equation 2 and 3, you see A is constant. So now what has been done to the concentration of B? B concentration is doubled. When B concentration is doubled, if you see, the rate has become 4 times, right? The rate has become here 4 times. That means when you are doubling the concentration and the rate is becoming 4 times, so that is a second order reaction. So second order reaction means with respect to B, it is a second order. So we can eliminate these two options. Now if we see the first with respect to A, B should be constant. So in these two reactions, 1 and 4, the concentration of B is constant. Now concentration of A is changed. So what is done? This concentration of 1 and 4 has been 4 times, like from point 1 to point 4, it has been like 4 times. And what has happened to the reaction? If you see, the reaction has also become 4 times, right? So if the concentration is 4 times, reaction is also 4 times, then it is a first order reaction. So here, this with respect to A, it is a, so I can write with respect to A, it is first order, with respect to B, it is second order. So KAB square. So correct answer for this question is option number D. Okay. Next. Okay. What will be the rate equation for the reaction 2x plus y is equal to z if the order of the reaction is 0? So if order of the reaction is 0, so here the order is 2, here the order is 1, here the order is 1, but here the order is 0. So the correct answer for this question will be option number B. Next, if the rate equation for the reaction is KAB half, the order of the reaction is. So we know order of the reaction is what? The sum of the power of the concentration terms. So 1 plus 1 by 2, that is your 3 by 2, that is 1.5. So the order will be here 1.5, right? Next question. An endothermic reaction with high activation energy for the forward reaction is given by the diagram. Okay, so if you know this one, in endothermic, the product energy will be higher, right? This will be the diagram. So the diagrams where product energies are less can be eliminated. Now the question has also mentioned high activation energy. So here the activation energy is very high. So the correct answer for this question will be option number C. Okay, very easy one. Next. A reaction is given as 2P plus Q gives product if the concentration of Q is kept constant and the concentration of P is doubled, then the rate of the reaction is. So if I want to write the rate law for this one, I'll write Kp square Q. See, every time the coefficient will not be equal to order, but for elementary reactions we can take where the coefficient of the reaction or the reactants is equal to its order of the reaction. So now what is told? P is doubled, so 2P Q, right? So that will be equal to 4 times. Okay. So the reaction is quadrupled. So the correct answer for this question is option number C. Okay, next. 3A plus 2B, the rate of the reaction dB by dt is equal to. So we can write first the differential rate law, minus 1 by 3, minus 1 by 3 dA by dt, okay, will be equal to 1 by 2 dB by dt. Okay, so now what will be equal to dB by dt? Is equal to minus 2 by 3 dA by dt. Okay, So that is your option number B. So correct answer for this question will be option number B. Very simple and easy question. Next one. 90% of a first order reaction is completed in 70 minutes. The velocity constant of the reaction is. Velocity constant is nothing but your rate constant. Okay. So first order reaction, we know the integrated rate law for first order. K is equal to 2.303 by T log of A naught by A. Right. So now if you see 2.303 times 70 log of 90% is completed. Okay, then how much will be left? 10%. So log of 100 by 10, that is log 10, which is 1. So we need to calculate for 2.303 by 70. Okay, so the correct answer for this question will be option number A, that is 0.0329. Okay, you can just see 70 into 3 will be 210. So something related to that. So that will be 0.03. Okay, next. This is your hydrolysis of acid hydrolysis of ester. So we all know this is an example of pseudo-unimolecular reaction. So correct answer for this is option number A. Direct fact based question. Next, how enzymes increases the rate of the reaction? So enzymes provide an alternative pathway which reduces the activation energy of a reaction. So that is why they do so by lowering the activation energy. Okay. So the correct answer for this question is again option number A. Very easy one. Next question is, okay, this is one important question. For a reaction X to Y, the graph of the product concentration versus time. Okay, the graph of product concentration versus time is a straight line passing through the origin. Okay. Okay. So now if I see, we have this equation. If it is a straight line passing through the origin, product concentration divided by time. Okay. Now if you see, I can write rate is equal to, for a zeroth order reaction, if I take, is equal to dP by dt is equal to K, right? So now this one is a slope is K and this is a straight line passing through the origin. Now the question is asked, hence the graph of minus dx by dt and the time would be. Minus dx by dt is your reactant, right? So for a zeroth order reaction, it doesn't depend on the concentration of the reactant, right? That is what is the meaning of zeroth order reaction. So how the graph will come? With reactant concentration and time, if you take, it will be a straight line. It doesn't depend on the initial concentration of the reactant. So it will be a straight line parallel to x-axis. So the correct answer for this question is option number C. Okay, next. In a chemical reaction, A plus 2B gives product. So we have A plus 2B gives product. The concentration of A is double, the rate of the reaction increases 4 times. So when you are doubling it, it is becoming 4 times. So with respect to A, it is a second order reaction. And when the concentration of B alone is double, the rate continues to be the same. That means with respect to B, it is a zeroth order reaction, right? So what will be the overall order of the reaction? 2 plus 0, that is 2. So the correct answer is option number B. Next. The rate of a chemical reaction doubles for every 10 degree rise in the temperature. If the temperature increases by 60 degrees Celsius, the rate of the reaction increases. Okay. So this is from your temperature coefficient part, right? So for every 10 degree, like for every 10 degree, the rate doubles, right? So just you have to calculate from 0 degree to 60 degree. Okay. So from 10 degree, 20 degree, 30, 40, and then 50. Right. So 1, 2, 3, 4, 5 and 6. 6 times we have done. So that means 2 to the power of 6, that is 64. So the correct answer for this question is option number C, that is 64. Okay, next. An endothermic reaction A to B has an activation energy of x kilojoule per mole. Okay. So let us draw this. We have an endothermic reaction. So in endothermic reaction, the graph will be like this. This is A, this is B. The activation energy is x kilojoule per mole. Okay, next, if the energy change of the reaction is Y, so this is the energy change value is what? Energy of the reactants, energy of the products minus the energy of the reactants. So this one will be Y. Okay, next, the activation energy of the reverse reaction. So we have to calculate this value. Okay, So this total value is X, this value is Y, this is the activation energy of the reverse reaction. So this value is your what? X minus Y. So the correct answer for this question will be option number B. Okay, very easy one. Total value is X, this one is Y. So what will be this value? This value is nothing but X minus Y. Next, AP plus BQ product. So there is a reaction when P is doubled, keeping Q constant, the rate increases by 2 times. So you are doubling P and the rate is also becoming double. So with respect to P, it is a first order reaction. Then when P is constant and Q is double, the rate increases 4 times. So when you are doubling Q but rate is becoming 4 times, then it is a, with respect to Q, it is a second order reaction. Then what is the overall order of the reaction? That is 2 plus 1, 3. So the correct answer for this question is option number C. Next, for a reaction between A and B, the order with respect to A is 2, okay, and the other with respect to B is 3, okay. So this is the rate. Now what you have done, the concentration of both A and B is doubled. So we will have R 2A and then 2B, okay. So we have here, so I can write 4A square and 8B cube, okay. So we'll get 32 times K A square and B cube, okay. So the correct answer for this question will be 32. The rate has increased now by 32 times, okay. So easy question. Next, a reaction is 50% complete in 2 hours and 75% completed in 4 hours. The order of the reaction is. So if you see here, 100 was there, okay. Initially 100% was there, then 50% was completed in 2 hours, okay. The next half, that is 50 plus 2, next half will be 75, means from 50 to 25. That will again converted into 2 hours. So now 100 to this one is your 75%. So now if you see, the half-life is not depending on the initial concentration. When the initial concentration was 100, the half-life was 2 hours. When the initial concentration is 50, then also the half-life is 2 hours. So in this occurs in your first order reaction, right? So the order of the reaction is first order. Correct answer is option number A. Okay, next, the time required for 100% completion of a zero order reaction is. So for zero order reaction, what is the value? A naught minus A is equal to KT, right? Now if you see that the final concentration, this 100% completion of the reaction. So I can write A naught, this one will be 0 is equal to KT, right? Now T value will be equal to A naught by K or A by K. Okay. So the correct answer for this question is option number A. Next, decomposition of NH3 on the surface of platinum has a rate constant of 2.5 into 10 to the power of minus 4 mole decimeter cube second inverse, okay. The order of the reaction is. So this is how the formula to calculate the rate order of the reaction using the rate constant. So you should know the general formula of rate constant, that is mole 1 minus n, liter n minus 1, second inverse, right? So in this question, what is the unit of moles? Moles unit is 1. So I can write mole 1 in place of liter. 1 liter is 1 decimeter cube, okay. So I can write decimeter cube and that is minus 1 second inverse. So we can equate these two. So 1 minus n is equal to 1. So n value will be equal to 1 minus 1, that is 0, okay. So the correct answer for this question will be option number A, that is, it is a zeroth order reaction. Next, the rate equation of the gaseous reaction is given by KAB if the volume of the reaction is suddenly reduced to half. So if you know what is the formula of concentration or molarity, is number of moles by volume. So if volume is reduced to half, concentration will increase. So if it is half, it will be doubled. So now when the volume is double, what has happened? The concentration will become 2 times now, okay. So that will be equal to 4 times of K, A and B. So what will be the reaction rate relating to the original rate will be 4 times, okay. So correct answer for this question will be option number B. Next, the 6.25% of radioactive substance is left after 480 minutes. The half-life period is, okay. So we know all the radioactive reactions are your first order reactions. So I can write here K equal to 2.303 by T log of A naught by A. Okay. Now, if I solve this, what we have to put? 6.25% is left. So, we can write 2.303 by 480 minutes. Okay. And log of 100 by 6.25. Right. So, I can write it as 2.303 by 480 log of 100 by 625. Okay. So, we can solve this value. So, whatever value we get here is K. Now, T half value is of 0.693 by K. So, what you have to do? Just substitute the K value that we get here and in this, and then you have to calculate the T half value. So, if you calculate it, like if you substitute it correctly, the value you will be getting around is around 120 minutes. Okay. So, the correct answer for this question will be option number D. Okay. Next. In case of reversible gaseous reaction, a positive catalyst. So, what does a positive catalyst do? It increases the rate of both forward and backward reaction by increasing the activation energy. So, activation energy will decrease whenever the rate of reaction has to increase. So, increases the rate of both forward and backward reaction by decreasing the activation energy. So, option B is the correct answer. Next, with respect to the velocity constant, means that is your rate constant K of a reaction, which one of the following statements is not correct? Okay, this is very important when questions is asking incorrect, correct. So, be very careful there. So, it is a measure of velocity of the chemical reaction. Yes, this statement is correct. It is about the rate or the how fast a reaction is. Second, it is dependent on the initial concentration of the reactants. No, rate constant depends only on the temperature. It depends on the temperature. This is correct statement. During the progress of the reaction, even though the velocity decreases, the velocity constant remains constant. Yes, rate constant value is always same for a particular reaction. So, the incorrect statement for this is option number B. So, the answer for this question will be option number B. Next, which one of the following is an example of pseudo first order reaction? So, we have two examples if you remember. Alkali hydrolysis is incorrect. Acid hydrolysis of ester is an example of pseudo first order reaction, and another is your inversion of sucrose, that is acid hydrolysis. So, correct answer for this question will be option number B. Okay. Yeah, so these were the top 30 questions, or these were the previous year questions that were asked in your COMEDK exam. So, you can see mostly the questions are asked from the topic order of the reaction and then to calculate the rate law. Very few questions are like from the Arrhenius equation is there. So, just practice such questions, and if you have any doubt in any question, please comment down. We will be addressing it in the next video. Okay. So, practice hard, prepare hard for your exam. All the very best. If you have found this video helpful, so please share, like and subscribe our channel for such informative videos for your preparation. Thank you.